Okay, so for the blank proofs, everything that is in the given I already copied on line 1, so it's not going to be split up. Okay, it's just all on line 1. You'll also notice that it's also marked. You may want to draw attention to your parallel lines, because anytime you have parallel lines, you're going to use them to identify either alternate interior or whatever. So when you're doing the proof, the first thing that you're going to write in the statement column could be different than what I write. There's multiple things that don't have to go in an order. But you need to identify something else that's congruent in the picture. As soon as you identify it, I suggest you mark it and then write it down. So usually students like to identify first the shared side. A shared side is a side that's showing up in both shapes. We know it's congruent to itself. So I would say that segment AC is congruent to segment AC. I would hope you would have gotten that because it was in the proof from yesterday. The reason for that, Halen just told us above, is the reflexive property. All right, so now we have all the corresponding sides are congruent, so that's done. Sides, 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 done. Now we need to prove angles. We do have one pair of angles that are congruent, which are B and D. Now, based on the parallel lines, we know we're going to use a type of angle. Typically, you are going to use AIA, alternate interior angles. So remember, alternate interior angles have to touch a parallel line, and they have to touch a transversal. And right now, we only know the parallel lines of the left and the right. Can't call this angle A, though, because there's multiple angles. So we have to use 3 letters. So for example, angle BAC or angle CAB is how you would name it. So we would write that down. Angle BAC is congruent to, and I'll mark that, 2 congruent markings. Who thinks they could name this angle using 3 letters properly? Jeremiah?
Angle ACD.
Angle ACD. Very good. And we just said those are alternate interior angles, so that's the alternate interior angle theorem. Or if lines parallel, AIA congruent. Now, we have 2 angles congruent to 2 angles. We can prove the third angles are congruent by the third angles theorem. We also have to use 3 letters on those ones. So this would be angle BCA is congruent to angle BCA, this one up here, and that would be DAC or CAD. And that's our third angles theorem. We now have 3 pairs of congruent sides, 3 pairs of congruent angles. We're done. We rewrite the proof statement down here, which is triangle ABC, congruent to triangle CDA, which you don't have to even think about the order they give it to you for corresponding parts. And this would be the definition of congruent triangles or polygons. Okay. Now the next one was similar, but it did have some different elements to it. We don't have a shared side in this picture. So we have a bunch of given stuff. We also have a phrase, and anytime I see words, I usually like to use those first just because they're part of the given and we have to conclude something. So it says PQ bisects RT. Who remembers what bisect means? Bisect. Lauren? Cuts it in half. Or it also cuts it into 2 congruent parts. Okay, another way to think of it. So whatever comes at the end is what's being cut. Whatever comes at the beginning is what's doing the cutting. So PQ is cutting through RT, creating 2 congruent segments. So I would mark that in my picture. This is cutting through, bisecting through RT or TR. Now I write that in my proof. Segment TS is congruent to segment SR. Remember what we said about words when we had like midpoint, we'd say definition of a midpoint. So this needs to be definition of a bisector. Which type is it? It's a segment bisector. I did see a couple of you with angle. None of the angles are being bisected, just the segments. So now we have all the sides congruent to all the sides. 1 marking, 2 markings, 3 markings. Sides are done. Now we go to angles. We do have a pair of parallel lines. Here and here. So we're probably going to use alternate interior angles most of the time in these proofs.
Please excuse the interruption. Any students going with Mrs. Burns on the field trip this morning, please report to the front lobby at this time. Thank you.
So these two angles are alternate interior. We can just call them P and Q. We can make it nice and easy because that's the only angle that touches at P. So I'm going to say angle P is congruent to angle Q. And that would be, again, our alternate interior angles theorem. Do you see another pair of alternate interior angles in this picture? Does anyone see another pair? Kel? Angle T and angle R. They're also along a transversal and touching the parallel line. You actually can put this on the same line since it's the same reason. Okay, if you wanted to put it on a separate line, you'd say AAs again. Okay, so now we have 2 pairs of angles, so the middle angles will now be congruent. There's one of 2 ways that we can say why. We do have to use 3 letters here because S has multiple angles associated. So angle PSR is congruent to angle QST. And you have 2 options here. Who has an idea what one would be? Yeah? Third angles there. Or, what type of angles are those? Kel? They're vertical. So you also could use the vertical angles theorem. It doesn't matter which one you put, they're both fine. Now, you could have used vertical angles first. You could have used 1 pair of alternate interiors, and then you could have done third angles for the other pair. There's different ways to do it. Now we're done. Triangles are congruent. I'm going to save time. I'd copy that down here. And that again would be definition of congruent triangles. Now, lucky for you, you'll never have to do a proof like this again. Okay, today we're going to learn shortcut theorems so that we don't have to prove all the sides are congruent to all the sides, all the angles are congruent to all the angles. We'll learn some postulates that will shortcut this for us. And that's our side, side, side postulate and our side, angle, side postulate. So we'll only have to prove 3 things are congruent instead of 6. Okay. All right, we are going to skip the warm-up because I took kind of a long time on the homework, and that's not really that great. But today we are proving triangle congruence by side angle, side, 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 and side angle, side. Tomorrow we'll learn 2 additional shortcuts, but today we're just learning 2 of the 4. 2 of the 5. All right, so in the past section, in order to prove the triangles are congruent on the homework, we had to prove 6 steps, basically. We had to prove that there were 3 pairs of congruent sides, and we had to prove that there were 3 pairs of congruent angles. Now, a lot of that was usually given to us, but nevertheless, it was kind of a long process to get all 6 pairs. In this section, we will learn shortcuts to prove triangle congruency. And from today on, you'll never have to do a proof like yesterday's because you'll get to use the shortcut. So there won't even be one like that on the test. Well, there will be, but you'll get to use the shortcut instead of doing the whole thing. If you wanted to do the whole thing, you still can. But obviously, less steps is always more easier to do. So this first one, I don't know why it's cut off my board, but it's the side, side, side postulate, which is the SSS postulate. And this says that if there are 3 sides of one triangle that are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So this shortcut is saying if we can prove 3 sides congruent to 3 sides, we're done. We don't even have to look at the angles. This will be enough to justify. And just doing a little triangle congruent statement, I could say triangle GHF is congruent to. Who thinks they could complete the congruent statement? me with the proper letters, Jeremiah?
PQR.
Good. My board's like shaking again. Sorry if you didn't notice it, now you notice it. All right, this one's pretty easy. You just look at the sides. Are they marked congruent, or do they have numbers that show they're congruent? The side angle side, the SAS postulate, obviously two sides and one angle, okay, but the angle has to be a specific type of angle. So two sides, and it's called an included angle, meaning the angle is in between those two sides. SAS, that's why it's called the SAS postulate. Okay, so they have to be like butted up right against each other, as you can see here. Here's the two sides. The included angle is the one that's in between them. If you can prove that we have SAS, then we have triangle congruence. That will be enough information to prove the triangles are congruent. And sometimes you'll see me, not all of you will need to do this, but sometimes you'll see me write side A for angle and side to make sure that it does use SAS. Okay, you want to make sure the angle is directly in between the two sides. So again, you want to pay attention. If you were to see something like this, one marking, two markings, and an angle, this is not side angle side. Everyone gets a kick out of this. It's SSA or it's ASS. That is not a postulate. It's not a postulate just because it spells a bad word. It just isn't enough information to prove triangle congruence. But that's an easy way for you to remember that it won't work. Now some students will do this. They'll be like, oh, SAS. Oh, it's SAS. Remember, the side would have to be adjacent to the angle. Okay? So an included side would be, for instance, if we had this side, and this angle. This would be SAS. And tomorrow we'll learn two other shortcuts, but today we're just going to focus on the first two. So we have a ton of questions. We won't necessarily go through all of them. We are still going to have to add in some markings based on vertical angles, shared sides, parallel lines, bisectors, etc. But all of them basically tell us the same question. Are the triangles congruent? Mark them appropriately if you need to. If yes, complete the congruence statement and state the theorem or postulate that supports our answer. If not possible, just write not possible. So this one, obviously we can see side, 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 side. This one is a yes. So we would say, and you can write this however you want for the first one. For example, I'd say triangle KLJ is congruent to triangle MON, and that would be by side, side, side postulate. I do let you just write side, side, side for these. I don't know why I get lenient in this chapter, but I do. So you can just write SSS. Okay, the next one, we can see that we have a side, an included angle, and another side. And we have a side, an included angle, and another side. So these would be congruent by SAS postulate, the side angle side postulate. So triangle PQR is congruent to corresponding parts would be NMO. Okay, now example C does have a given statement. So we want to use that. F is the midpoint of IG. So using the definition of a midpoint, what could I conclude and add into the picture? Marquise?
Segments IF and FG.
Good. We would say segment IF, if we were doing a proof, is congruent to FG, and that would be definition of a midpoint. You don't have to write that out now. I just try to help us get in a proof state of mind for when we get there. So based on that information, you can say they're congruent by which postulate? Side, side, side? Yeah. Now you could also add something else in though. Did anyone see it? Vertical angles. So if you wanted to, you could add in vertical angles as well, and then you would have side angle side as well. So I'm going to go ahead and put triangle EFI. Now be careful. This is one that students will screw up on their quiz next week. People will think since it's EFI, it's GFH. It's not. Pay attention to the markings. It goes 2, then 3, then 1 on the sides. So you have to go 2, then 3, then 1. This would be HFG. It's not always like top. This has been like twisted and then reflected. And this would be by, and I would accept SSS or SAS depending on how you marked it. Your markings are actually worth points on your next quiz. So make sure that you would mark it appropriately. What do we think about D? What could we add in? Maddie? Good. MK is congruent to MK. Reflexive. So are these congruent? Yes. Side, side, side. Who could complete the congruent statement for me? Be careful. And if you struggle with this, write the markings. So J to M is a 2 marking, then a 3 marking, then a 1 marking. So you want to follow that same order. 2, then 3, then 1. So who can complete it for me? Brett? LKM. Okay, E. Am I allowed to just do this? Am I allowed to just add in side markings like that? No. Unless they tell you a given, you can't just add them in because you think they look the same way. What can I add in? Marquise? Angles. We should see that we have vertical angles. So again, you'll get a half point for putting that in your picture next week. Are these triangles congruent by SSS or SAS? No. We have side, the angle's not right here, side, angle. So this would be, okay, which are not a theorem or postulate. So this is not possible. And if it's not possible, you do not complete the congruent statement because they're not congruent. So you just write NP, cross it off, NP. Not possible. How about the next one? Nothing I can add in because they're not even touching. Are these congruent by SAS? No. This would be SSA. So again, not possible. Try these 3 on your own real quick. And then we might skip a couple. Oh no, I think we can get them. What do we get for G? What do we mark? Shout it out. VW, VW, or you can call that a shared side too if you want. Shared side. Are these congruent? No. The angle would have to be included. SAS. It's SSA. Not possible. How about the next one? No. Be careful. This is SAS. That one's good. This one is SSA. I don't know my pen's doing that right now, but it doesn't have the included angle over here, so this is not possible. And then this last one, we should have marked our shared side. So this was possible by side, side, side. And actually there's 2 different ways you could name the congruent statement. Since these are both congruent, it doesn't really tell you which way to go. So WZD, you could have SZD, or you could have SDZ. It actually doesn't matter since they're both having the same marking. And that would be by side, side, side. Now the last few have some given information, well some of them do. We're going to skip J. J would be not possible. I guess I'll do it. And that's because we don't know the third sides are congruent. Make sure you don't think you can just add markings in. These aren't marked, so we really just have SS, which is not enough information. Okay. Now this one we have, these are supposed to be parallel markings. They're just slanted for some reason. And when we get to proofs on the next page, most of you like the shared side. It's like your favorite like little security blanket. It's the first thing you'll do on the proof, which is perfectly fine. So for this one, as soon as you see it, mark it. On the next page, when we do a proof, we would then write that down. FK is congruent to FK, we're flexible. And we have one side congruent to one side here. We have to use the parallel lines, just like we did on last night's proof. So we should notice we have alternate interior angles, so mark them. You don't have to justify it all in a proof, but we would use 3 letters and say they're congruent by alternate interior angles theorem. So are these triangles congruent by side, 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 or side, angle, side? Let's check and see. We have side, angle, side, that's an included angle, and we have side, angle, side, so yes. Now this congruent statement is one that a lot of you will screw up the order of on your quiz. So again, be careful. F, L, K. So this has no markings, then 1 marking, then 2 markings. So 0, 1, 2. Follow the same pattern. 0, 1, 2, which would be K, J, G, F. K, G, F. 0, 1, 2. Last one says that A, E, and BD bisect each other. So Lauren reminded us that bisect means to cut in half. It actually means that they're cutting each other in half. So one of them is cutting one of the other ones in half. So we could say DC is congruent to CB. The other segment happens to be cutting the other one in half. Now you do want to put different markings because they're not saying they're all congruent, they're just saying they're both being cut into 2 congruent parts. So based on this, this would be the definition of a segment bisector. We can mark that information. These 2 are congruent and those 2 are congruent. It's like C is the midpoint of AE and C is the midpoint of DB, but they're different. And then what else can I mark in this picture? Marquise? Angles. Vertical angles are the only thing you can mark. We do not know these are parallel, so we can't use alternate interior angles. And that would be the vertical angles theorem. So now we have SAS, SAS. So these are congruent. Who can complete the statement for me with the correct ordering for the letters? Brett?
EDC.
EDC. So it was 0 marking, 1 marking, 2 marking. So he went 0, 1, 2. Excellent. Okay. We do have more on the next page, sorry. We have a couple proofs. This one I think there's on the homework. You'll see some of these, that's why I threw it in here. It just changes the question to what other information do you need to know to prove that these are congruent? That does not mean things you can conclude on your own. It means what additional information would you have to know. So for example 2A, we know KS is congruent to KS. I don't want you to write that down because we don't need to know it. We already know it. So what other information would we have to know to prove the triangles were congruent? There's 2 optional answers for this. Brett?
RK is congruent to TS.
Good. If we knew RK was congruent to TS, then we'd have side, side, side. That's the easiest one. You also could choose angles. And just to shorten time, I'm just going to put a 1 and a 2 in here, so we don't have to use 3 letters. We would have to know that angle 1 and 2 were congruent. Those would be alternate interior, well, could be alternate interior angles, and then that would prove SAS, SAS. But you only need one of those 2 answers. Okay, the next one, notice we have these being marked as congruent. Obviously, the middle one is congruent to itself. So what else would I have to know to prove the triangles were congruent? Jeremiah?
I have a question.
Oh, yes.
What if they were parallel? RS?
You could also say that, yes. If you knew RS was parallel to KT, that would be enough information for you to then conclude 1 and 2 were congruent. That would work. Very good. I have that written down, my favorite too. All right. For B, what would I need to know specifically? I need to know something is a certain length. Katie? Good, we'd have to know that this is 8. That would prove side, side, side. Now you also could get creative and say, let's just call this angle 1 and angle 2 again, just for sake of time. You could also say 1 and 2 are congruent, because that would do SAS, SAS. Or you could do what Jeremiah said, which was AB is parallel to CD. Again, these are all ors. You wouldn't have to write all of them, just one of the 3. Okay. Last thing are our proofs. So let's take a look at the first one. You can see that we have some given information. You do want to put the given information in your picture. So angle XAM is congruent to angle YAM. Mark it. Segment AX is congruent to segment AY. If you don't mark the given, there's a good chance you're not going to know how to do it. And then you have to add stuff in. So what else would I add into the picture that I know is congruent? Marquise? MA. MA. We have a shared side. As soon as you mark it, you write it down. AM is congruent to AM, or MA is congruent to MA. Doesn't matter the order. That's our reflexive property of congruence. Now last night we then had to prove 3 more things, but now we don't. We now have SAS and SAS, so we're done. That's why there's only 3 lines. We would copy this proof statement down here, and then we would say SAS. And if you want to put the postulate, you can, but I actually don't make you. You can just write SAS. Okay, we're not going to get to the second proof. I will do it on the video.